Hello, my dear students. Just to remind you of what we're doing, we are discussing a topic about the exponential and logarithmic functions. So we started looking at it and we do it bit by bit. I first of all had to introduce you into what exponential equations are and what to model them. I have a hope that you know that. In case you are joining us for the first time, the same advice is given to you that please revise the previous video first before you take into today's business in this video. Right, so we discussed what exponential equations are and also what logarithmic equations are, and later we had also to see the relationship that is there between what we call them as the exponential equations and the logarithmic equations, because this is just like a two-way system. The moment you deal with the logarithmic, it means you need to have knowledge about what? Exponential. Right, so in the relationship that we discussed in the previous video, that what I can request you is just like amount of, say, getting more, let's say getting into depth on the way how you can relate the two equations, exponential and logarithmic. You should be able to convert exponential to logarithmic. Be again in the position to convert the logarithmic toward exponential equations as such. Like maybe before I take into today's discussion about the laws of logarithms, let's just have one discussion on how we can convert either logarithmic to exponential, exponential to logarithmic, just to start the ball rolling in that way. For example, if I can have my exponential equations, which is like talk of m raised to the power h is equal to p, right? Just like p is expressed to base m, and you're telling us that, say, how many m's can we multiply to get a p? So this one is an exponential equation. So you might be able to ask to convert this one into logarithmic. I should I have that hope that you are there to know how best you can convert this exponential into logarithmic. Right, we always indicated that, say, this power here of m represents a number signifying that how many times do you multiply m in order to get a p. So this how many times, which is indicated like a power equal to the exponent, that the same is what is defined as the logarithm of p in factors of m. So as such, if I'm going to convert this exponential equation to logarithmic equation, this logarithmic equation of which will be like log of p to base m is equal to h. So that's the relationship. So try at least to go through this and be able to master the skills as such to say if I've got, let's say, talk of h raised to the power x is equal to maybe talk of k, realize that is exponential into logarithmic. This should be logarithm of k is written on top, and h comes down is equal to x. To say that talk of talk of h can be multiplied x times to get a k. That's what it means there. Fine, that was it about that. Go through the exercises and the lights so that you have to see how this discussion is applied. The previous video are going to give you the depth of the discussion of that. Today, what is it that we have? What we're saying now is just like problems we have in the exponential and logarithms. Sometimes they cannot be treated directly. Remember what I said on how you can solve the exponential equation. What I said was just like to solve the exponential equation, you need just have to express the term to the same basis. See what we did in the examples. And when we also talk of solving logarithmic equation, we said if you like to solve logarithmic equation, it's just a situation whereby you first have to know how you can convert the logarithmic equation to what? Exponential. So if you are able to convert the logarithmic to exponential, it means you can just solve the exponential equation of the logarithmic of which. That's the way we do. So in short, solving logarithmic equation, we solve by converting it into exponential, the situation which you already know how to handle it, and then solve the exponential equation of which. So now what we're saying is that the might not be sometimes direct to do that, just converting the exponential into logarithmic. That's some problem that needs more application that cannot go further such. So what we do here, we are going now to discuss the in detail, so say another phase of talk of the knowledge that can help us to solve that type of situation. And this new knowledge is something that is related to what? Laws. So it means that some kind of laws in logarithm which are applied in such a way that when you fail to solve or work out problems in the logarithm directly by the method we discussed, you can be able just to apply the laws which we are going to discuss here. So it is worth it to know these laws, and thereafter we are going to discuss how these laws are applied. So please take your time here. This is the crucial part of this topic. Most of the questions which come in your exam, they always need you to apply this type of knowledge. So please, let's be together. And when I discuss with you, try to take much time to replay the videos now and again, and you really master what we're going to discuss here. Right, which are these laws that we need to know? That when I meet such problems, I need to use them. Right, in logarithms of numbers, when we talk of logarithm of numbers, here we'll be referring to only those logarithm of numbers which are expressed to the same base. If you are doing a certain operation to such logarithm of numbers of the same base, what is it that you need to know? For example, I may have a situation like logarithm of talk of x, talk of 5 to base 6. You are doing the operation by addition. You are adding with the logarithm of talk of a different number, can be 80 to base talk of 6. They may ask you to evaluate this one out. So it'd be like, now, how can I handle this one? And you know for sure these are not like terms, because here we would have just added the two directives that are like terms. And here you cannot be able to think of expressing this one to exponential. It's not easy. So in this type of situations where now we need to see how we can deal with this. So this will be handled when we know the laws. Right, so here we'll be just discussing with the logarithms of numbers like 5 and 8, which are expressed to the same basis, like a 6 and a 6, or 5 and a 5, or 10 and a 10. Right, so to be quick in the discussion, the laws are not all that difficult, but here and here I'll be able to at least give you the counter examples so that you should be in the position to at least accept the knowledge of which. Right, firstly, the laws that we need to discuss here should be able to be captured in two phases. In short, we have got two sets of laws. Right, when I discuss with one, try also to compare with the other set. So how does it compare? Are they just similar or a little bit different? And those are the direction the way a question will come. So the two sets of laws, we have got two sets of laws. One set is a set of laws, okay, is a set of logarithm, okay, logarithm of numbers whose bases are indicated. For example, we can talk of the logarithm of 6 to base 9. So if you talk of logarithm of 6 here, the base indicated as a 9. So we discuss the laws of logarithms whose bases are indicated like a 9. Another set is a set of laws whose bases usually are not indicated. Like say for example here, if I've indicated, say log of 6 to base 9, 9 is the base in this case. So here a base is indicated. That's what I mean here. But now when I say base is not indicated, we will talk of situations that we apply the laws of the logarithm of numbers, like log of what? A 6. Why here a base is not indicated, like here is a 9. Right, so what is it that we know about this? Right, so first set is the logarithm of numbers whose bases are indicated, and secondary logarithm of numbers where bases are not indicated. Right, so firstly, let me talk of this situation here. Where bases are not indicated does not necessarily that that term, that expression doesn't have a base. The base is always there. Such type of situations, we call them as such type of numbers whose bases are indicated. We categorize them as logarithm, or categorize them as natural logarithm of numbers. And the basis is there and is defined as a base, as a 10. To mean that if I write log of 6, I write log of 10, I write log of what? Of a number like x. What does this mean? This simply means the logarithm of 6 to base 10. If I write log of a 10, this simply means the logarithm of 10 to base 10. When I write log of x, that simply means the logarithm of x to base 10. So such things, first of all, when we when we're discussing about the laws of logarithms, we need at least to know. So there's a lot. Besides knowing the laws, let us also try to understand the depths of the logarithm of numbers. So firstly, please, students, try to understand when we be discussing about the laws of logarithms, take it into two phases to make it simple, logarithm of numbers base indicated, logarithm of numbers base are not what? Indicated. So where bases are not indicated, take that the base is what? Is a 10. So it may be like whatever I'll talk about the logarithm of numbers where bases are indicated, I have or hope that you are already there that say we'll be able to do the same discussion about the logarithm of numbers whose bases are not indicated, because we know the base is always what? A 10. Right, so now let us now take note about these laws. What are they? So what I'll do here on the board here, I'll write the laws in such a way they'll be in pairs where necessary, where base is indicated and where the base is not indicated, so that we have to compare what is there, and then we'll be able to master them fairly well. That all the laws are, or laws of logarithms are defined by this, it means this. When defined by this, it means that. Right, one is a law that is related to multiplication. So we talk of the multiplicative law. Multiplicative law. So what is it about multiplicative? Well, we'll be meeting situations in the operations of logarithm of numbers. That's the problems, right? But now this logarithm of numbers will have the same base as area indicated, where you'll be required to add it. So for example, I may have by the first set 1, that's it, where I have bases indicated. I may have a situation whereby I'll have maybe logarithm of a number x to base a is added with the logarithm of a number y. Y can represent any number as a variable, and x representing any number as a variable. But here now we talk of addition. The terms are adding here, strictly for addition. But the base is also a. Right. So it'd be like in the exam, you need to solve this one out, this plus this. You find that it's a problem. You can't add it. So it's more like, how can you handle this one? So it's when it comes to a situation whereby you need to know the law. The law is more just like, how do you handle this also? How do you like this one in a different way? What does this mean? If I let things happen, how else can I like that? So those are the line of what? Understanding about the laws of what? Logarithms. Right. So here, whenever we talk, or we have got logarithm of numbers which are added but are of the same basis, like a 5 5 7 7 8 8. Here, this situation is the same as just multiplying the numbers themselves, but expressed to the same base, which is a. So here, if I've got log of x to base a plus log of y to base a, this is as good as having logarithm of x multiplied by y. That one should be expressed to base what? To base a as such. Right, that's what it means there. And then if we don't have the basis, then definitely we have a situation like log of x plus log of what? Log of y. But understandably, we have said that the basis, though it's not indicated, we know that the basis are 10. So it's as good as having the base itself where we have got a. If a is 10, it means here it must be a. If a here is 10, then here it must be what? Must a be a. So here, this base a, this base a. It means you already know this base 10, this base 10. So it means when I'm adding logarithm of numbers with no basis, it means this is the same as the logarithm of numbers with the same basis up there, the operations of which. So which means here I will need also to multiply x times y and read it like that, considering or bearing in mind that the basis is what? Is a 10. So please take the logic that is here. It doesn't necessarily that we don't have the base. The base is just invisible, but it is there. So I'm emphasizing on this because this is the line of thought and your expectation to have the problems that we need you to demand to look at this one at least in detail. So please, log of numbers with the same basis, but we talk of the now addition. This is as good as just multiplying the numbers themselves. But now where we are having no basis, it means we are also multiplying as such. To give you a good examples on this, which can also be utilized in the other areas of concern, let us try to use a calculator. Go to the calculator there. If you talk of, if we are to use a device, a calculator, you are going to experience that one of the buttons that is there is written log. That one helps you to get you the logarithm of the numbers. Consider every time when you take the logarithm of a number there, you just place a number. Like say, for example, if I would like to have a logarithm of what? 100, I'll just place log 100. I don't even write a base. And when you press equal to, what happens there? The answer comes in as what? As a 2. Log of 100. The answer is what? Is a 2. Right. So by the way you understand what this one means here, by what we have discussed here, this is as good as saying, when somebody like this one, is as good as writing log of what? 100 to base what? To base a 10. And you can work this one out direct and get the 2, which you can get from the calculator. How can you get a 2? It's just by just understanding what this expression means. Earlier, when we were discussing about logarithm of numbers, remember what I said. When you write log of 100 to base 10, this simply means how many 10s can we multiply to get 100. That number of times is what you are going to write here in the answer. So you'll be able to tell me that the number of 10 that I can multiply to get 100, there are 2. That's why on the calculator, when you press log 100, definitely it can be a 2. Right. So that tells you in mind that say, oh, it means then the bases which are there expressed for the numbers on the calculator is a 10. So that's why here we mean when you have got a number, logarithm of a number, the base is not indicated. Consider that the base is what? Is a 10. So you press even log of a 3. You press log of 10 on the calculator. The answer you get there definitely is a 1. Which means I write log of a 10, it simply means logarithm of 10 to base 10. To mean what? How many 10s can I multiply to get a 10? It's only a single 10. And that's why here you write what? 1. And log of a 10 you get a what? Is the 1. Think like that. Now, from the first one, how do we get the multiplication as such? Let me give you a good example again here, just a good counter example why we need to multiply. This is as good as multiplication. Look at this. From what I've discussed, log of maybe 1000 plus log of what? Log of 100. Let's take it that say x is what? X is 100, sorry, is 1000 and y is 100. So if I press log of 1000 plus log of 100, this is as good as saying how many 10s do we multiply to get 100, and you tell me it is the 3. How many 10s can I multiply to get this to get 1000 is a 3. But how many 10s can I multiply to get 100? That is what is a 2. What answer do you get then is what? A 5. So definitely if you can just try to multiply this by this, what you have here is logarithm of what? You have got this times this. You will get that is talk of 100,000 when you multiply this by this. So if you take the logarithm of 100,000, is as good as how many 10s can you multiply to get 100,000? So the answer is what? Is a 5. Right. So here we need a master and calculator to say when we talk of the addition of the logarithm of numbers here of the same basis, please, this law is true and it's very applicable. This is good here, count example, and you can even compare it on the calculator. Right. So for the other laws, I will not even take much time. I need just have to go straight into them because you might do the same as what I've just done here. Right. Second law is about the division law. Division law. Right. It's just the opposite of this one. I'll also present this in two phases. Base are indicated, base not indicated. So here if I've got the first one, the first part, we'll be talking of the n logarithm of number like x to base a. Now, we talk about subtraction. You're subtracting log of y to base a. The opposite is true. You can get the same count example that I gave you, like the one I gave you. You'll be able to write that what we have when you subtract this one from this is as good as writing log of y, log of x divided by y. And this is expressed to base a. Then similarly, if we don't have the basis, what does this mean? That one means that's now the second set. You talk of log over x minus log of y. That is as good as writing log over what? That's the x over y. We take it for granted that the bases are the same. Right. So that's it. We have about the first two laws of what? Logarithms. Now, if we go into the another set of laws of logarithms, we have a situation which goes something like this one. This is C. This one, we need first of us to discuss a certain situation here, and out of which we are going to obtain law number 3. Consider this situation here. Log of, like, say, talk over 1000 to base 10. You'll be able to tell me that the log of 1000 to base 10 is as good as how many times do we multiply to get 1000? The answer is what? 3. So if I'm going to ask you a question, say, how else can we find the 3 from log of 1000 to base 10? So you'll be able to see that for this one, we can do a certain situation here. We can do a certain activity and obtain a 3 as such. What is that? Look at this. This, if we can try to figure out this 1000 here and try to make it into base 10, if it is possible, try to express this 1000 as it is here. It should be in the base 10. In the base, as the existing base here, 1000 should be in base 10. What do we have? We have log of, if 1000 is going to be expressed base 10, it will be 10 to the power 3. So the base here already is a 10. I've just converted this 1000 into this light up into more like exponential form. Like, so if I write 10 to the power 3 is as good as writing 1000. So you'll be able to realize that for I to obtain this 3, you can just try to think of transferring this 3 and come like a coefficient of the logarithm of what? 10 to base 10. So if 3 comes here, it'll be like 3 log of, you leave a 10 there and a 10 down like that. So from what we have discussed here, you'll be able to see that our statement about that light up, it always makes sense. When I write log of 10 to base 10, this simply means how many 10s can I multiply to get a 10. So here, definitely, you are going to realize that we have got to a single 10 that should be multiplied. So log of 10 to base 10 is as good as a 1. So since 3 is multiplying by this one, it means that you have got 3 times 1. And the answer I get is what? Is a 3. So our third law here is coming from this operation here. To say, if somebody likes this, it's as good as writing this. Something like that. Or else, not going by that to make you better, let us consider this situation, which starts from here, get into here, and get to that. Which means if this is equal to this and give us this, then after we can be able to figure out that say this should be equal to this one here. So the third law is there relating this box here and that box to say if I have got light up like logarithm over x to the power y to base a, this is as good as having 3 coming here. So here instead of having a 3, I have got a y going this way, and this we have that's a y log of x to base a, light. So this is the third law. But now on part 1. So if this part 2, where bases are not indicated, we should expect the situation of having log of x to the power y. This should be the same as having y that side, and then the 10 is already here. So you see we have that 10 invisible, so it means this one will be y log of what? Log of x. That is the other law that we need to know. Like the last one of our discussion here is just like application, but the main 3 laws that we need to know are the ones which have been highlighted on the board here. Please, they're just simple. Master them as they are. Just get to know how we are presenting them. Subtraction, addition. But remember, only bases, only for those bases are the same. Those are the kinds of the terms we're considering here in the operation of these laws of logarithms. The last one, that is the D, is just an application that is coming from this situation here of, say, when I write, for example, a situation like, say, logarithm of 10 base 10. This tells me how many 10s can I multiply in order to get a 10. We always say is what? Is a 1. And what if somebody writes like this? Logarithm of 5 to base 5. It means again, how many 5s can I multiply to get a 5? It's only 1 5. You can't have 2 5s. It'd be 5 times 5 is 25. So here you talk of what? It's a 1. What about if I write like this one? Log of x to base x. It's just like what? How many x can I multiply to get a single x? The answer is what? 1. So here we're taking for granted, say, any representation of logarithm of a number like x or set of a to base a, that is as good as having a 1. Right. But now for those whose bases are not indicated, there we are specifically looking at a situation about a base being a 10. So like here we are talking of a base the same like a number, it's a 1. So where bases are not indicated, we know that the bases are the 10. So we should expect that when I write logarithm of a 10, the answer here is just a 1, because this is as good as writing logarithm of 10 to base 10. Right, so this is what we have in the first part of the laws of logarithms. Just getting to know and understand the laws as such. Right, so I have a hope that you have this one and be able to master, such that in the next video where we're going to discuss the same laws now in the form of application in the examples, I know you'll be able to remember something about this. Please let us be together and now see how these laws we have just discussed can be applied into solving of the problems. But as of now, let's first of all just stop here and get prepared for the next video. Thank you very much for being together.